Assalamu alaikum. Today we are discussing the ATP design question, and I am using an IGCSE paper of this is an IGCSE paper February 2024. If you want to give a reference, you can. This is a student investigates the effect of insulation on the cooling of a liquid. Plan an experiment which will enable her to investigate how changing the thickness of insulation surrounding a beaker affects the rate of cooling of hot water in a beaker. Whenever you are solving a design question, you should try to read it at least twice. This is good for this. You have to read it twice because it always gets a problem. It always get into a problem if you access it in a wrong way. Apparatus includes a glass beaker, a supply of hot water, a lid to fit the beaker, strips of insulation which can be cut to size. So list any additional apparatus. So now suggest additional apparatus. We can do majority work orally because of the time constraint. What are the additional apparatus? Should I refer to anything else? The apparatus given here. Hmm. Thermometer and ruler. Do you think ruler is better, or should I refer to vernier caliper or something like that? Because insulation is not going to be very thick. It looks to be a strips. This is the thermometer and we have to put insulation around it. Insulation strips. So first you run the apparatus, you explain briefly how to do the experiment, including the measurements to take. So you can arrange the apparatus like this. We have a thermometer and you start the experiment. And he says, what are the key variables to, acha, you start the experiment and what will be the plan that you will start the experiment, record the temperature at regular intervals of time, and then plot a graph of temperature against time. The gradient of this graph will be the rate of cooling. State the key variables to keep constant. So can you tell me what are the possible variables which I should keep constant? Same initial temperature, huh? Right. Same liquid, same initial temperature and same volume. Huh, right, that's very good. So we will change the, we will repeat the experiment. We will repeat the experiment with different thickness, he says, which will enable to investigate how changing the thickness. So the experiment is done with the one insulation, then second insulation, then third insulation. For every insulation, we will repeat the trial in the same way. This is November 23. Now, this is my next question. You can give the reference. A student investigate the brightness of a lamp. Plan an experiment to investigate how the intensity or brightness of the light produced by the lamp is affected by the current in the lamp. Acha, how the brightness of the light produced by the lamp is affected by the current, the apparatus available, lamp and power supply, light meter, which measure the intensity of light arriving at it, an ammeter, and a variable resistor. In your plan, you should complete the circuit diagram to show the variable resistor connected to control the current. State the key variables to be kept constant. Explain briefly how to do the experiment. Draw a table with column headings to show how to display the readings. You are not required to enter any reading. How to use the readings to reach a conclusion. So I have a lamp, I have an ammeter, and variable resistor to control the current. So let's put the variable resistor here. So what are the key variables? I think we should take one variable as current. and other is the brightness. So let's mention the examiner that independent variable is equal to current. Dependent variable is the intensity. So now can you plan an experiment that how should I perform this experiment? So if you can share with me a short plan that in my opinion, we should start from maximum resistance. If I put resistance maximum, my current would be minimum and brightness would be minimum. So first I will isolate it from the room brightness and then I will start from high resistance. We will record the intensity at regular intervals and we will plot a graph of intensity against. We will plot a graph of the current again, y-axis intensity and x-axis current. How to use the reading to reach a conclusion? The shape of the graph can tell us how these two quantities are related to each other. In the table, you will be recording the amount of current and the intensity on different trials. This is the reference. Now give the reference and read the question. A student investigate the effect of changing the color of light on the focal length of a lens. The focal length of a lens is given by this equation. Distance u is the distance between an object and the lens, while the distance v of the distance between the lens and the image that is formed. Plan an experiment to investigate the effect of changing the color of light on the focal length of a lens. So, plan an experiment with the effect of changing the color of light on the focal length. So illuminated object, a selection of color filter to change the color of the light, converging lens, screen, meter rule. Other apparatus normally available in the laboratory can also be used. Draw a label diagram to show the arrangement of the apparatus and explain briefly how you would do the investigation, including the measurement you would take. Draw a suitable table. Now we have to plan it. Illuminated object, we have a selection of color filters we have. So we can change the color, converging lens, screen, meter rule. So you can draw with me. It will be a good practice to understand that this is the famous lens apparatus. And here we can put our lens. This is the illuminated object. Look at this. This is the filter. So you will tell the examiner that arrange the apparatus like this, move the move the screen forward and backward until a sharp image is produced. Repeat the trial, do the trial first without any filter. Start inserting the filters with different colors. Record the values of U and V and find the value of the focal length. This formula I'm talking about. Now read this question and make a plan out of it. I'm just coming in a minute. I have to say namaz here. So please read the question. Please read the question and make an answer. The figure 4.1 shows the setup. The power of the heater is constant. The following is also available. For water to evaporate to dryness when heated from above. And that the following is also step supply of water at room temperature, meter rule. Plan an experiment to investigate how one factor affects the time taken. That's also a good plan. We can investigate the effect of depth of dish. Another way, we can wait for the water to completely dry out and then use the stop clock for that and use the time as the ratio. How one factor effect. What are the factors? Explain briefly how you would do the investigation. State the key variable you would keep constant. Draw a table and explain how you would use your readings to reach a conclusion. So the power of the heater is constant. So actually, there is not clear what other factor. One is fine. The time, the power of the heater is constant. Supply of water, meter rule. So meter rule can be used to see the depth or the separation from the water. The height of the heater can also be judged by that. But one thing is think, thinkable here, that what other factor he wants to see, because the time taken for water to evaporate to dryness when heated from above, we can take one factor because power is constant. So we can decrease the separation. We can move the heater down, make it closer to water, or we can move the heater up, make it away from the water level so we can see what happens. I think we should do one thing, that we should use a clock and So this is my plan. I will change the factor. I'm taking the factor as the height and the time in which it totally dries out. So this is my plan. So I will change the height of the heater. I will change the height of the heater. I will change the height of the heater. I will record the time. I will record the time in which the water totally dries out. The water disappear from the dish. Any additional apparatus? So I'm taking stop clock. So I will repeat the trial from different heights. Every time I will run the apparatus, switch on the heater, switch on the time clock, and record the time in which all of the water disappears. Then I will plot a graph of height on x-axis and time on y-axis. March 23. A student investigates the motion of a ball through the air. Plan an experiment which will enable him to investigate how the range of the ball depends on the angle at which it is launched. Range means how long it can go. The range is the horizontal distance that the ball travels after leaving the edge of the channel shown and before hitting the ground. The apparatus available include, this is the apparatus, and the ball will come from the slope and it will go in the sky like a projectile. It will go in air like a projectile and then it will come down. A flexible channel, a flexible channel is given. A flexible channel is given a selection of balls, each of different diameter and mass. In your plan, you should list any additional apparatus needed. Explain briefly how to do the experiment. You may add to figure if it helps you explanation. State the key variables to control. Draw a table with column headings. How the range of the ball depends on the angle at which it is launched. Now, this is the apparatus. I have made some working on the apparatus already. So now suggest a procedure. Sorry. Now suggest a procedure. So this is the plan. The ball will launch from different angles. You can use a protractor. You can use a protractor and you can use a protractor, and using the protractor you can find the angle. Using a meter rule you can find the range. Then you can change the angle and launch the ball again. A student investigates the change in resistance of a lamp filament when the current in the lamp is increased. The following apparatus is available: a power supply, a low voltage filament lamp, an ammeter, a voltmeter, connecting wire. He wants to check the change in resistance of a lamp filament when the current in the lamp is increased. Other apparatus normally found in a school laboratory are also available. Plan and experiment. Investigate the change in resistance of the lamp filament when the current in the lamp is increased. Resistance is given by this equation where V is the potential difference across the lamp and I is the current in the lamp. Draw a diagram of the circuit. I have drawn this diagram. I have a rheostat, which I use to control the current. I have a voltmeter. I have a filament lamp, a meter, switch, voltage. So I will start with a high resistance of rheostat. I will start with high resistance of the rheostat, and then I will use the circuit. I will use the circuit to change different values of resistance. Current will change. I will record current. I will record voltage, and then I will use the formula R is equal to V upon I. I can find the resistance from this. And basically, actually, I can find the resistance from the formula. Current is coming from ammeter. So look at this diagram and see the procedure which I have explained. A student investigates the change in current in a conducting liquid as the distance between two electrodes is changed. Change in current in a conducting liquid as the distance between two electrodes is changed. Explain briefly how to do the investigation. State the key variables we can use. We have ammeter already in the circuit. Draw a table, state the key variables. Key variable, what you will change. So you can mark the distance here. This is the distance. So this is the apparatus. You will switch on the circuit, note the ammeter reading, measure the distance using a meter rule, measure the distance using a meter rule, then switch off the circuit, allow the circuit to cool, allow the circuit to cool down, and then change the distance, move them closer, repeat the trial, and then draw a graph of distance on x-axis and current on y-axis. A student investigate the rate of cooling of hot water in a container which has a lid. Today, the first question was like that. Plan an experiment which will enable him to compare the effect of lids of different thickness on the rate of cooling. And the apparatus available includes a beaker, supply of hot water, insulating material from which inlets can be cut. So you will plan an experiment and you will you can tell the examiner that So this is my beaker, this is my container, and I have to put lid of different types, and it contains the hot water. And I will take the lid. I will insert a thermometer in it, and we have to make a small hole in the lid so that our thermometer can pass through it. Now this is the apparatus, and then this is my lid. So I will use the thermometer. I will put hot water in it, and I will allow the apparatus to cool. And as the temperature goes down, I will record the values. This is how I will record the values. So I will find the graph, and the gradient is equal to rate of gradient is the rate of cooling. So I will take another lid. I will repeat the trial. I will find the gradient rate of cooling. In this way, I will do the experiment 5 to 6 times with different type of materials, different type of lids actually. And then I will record the values in a table to get the final answer. Conclusion, I mean. So we have done some design questions, and these are trial questions from IGCSE. So we are stopping here, and we will continue in my next class. Obviously, now the timetable is very stiff. Maths paper is coming, English paper is coming, and lot of pressure is there.